Hi all. Let's continue with the next part of data manipulation instructions of unit 2. Coming to the contents, we have already discussed an introduction to what are data manipulation instructions, and we have already seen arithmetic instructions and logical instructions. We'll continue with the remaining. So we have discussed about what are arithmetic instructions, what are the different types of arithmetic instructions, as well as logical and bit manipulation instructions. In today's lecture, we are going to discuss about the third type of data manipulation instructions, which are shift instructions. So shift instructions they basically allow the bits of of the register contents to be shifted one bit place to the right or to the left. So you can allow the bits of a memory location or a register contents to be shifted towards the left or right by one bit. So they are basically divided into three types: logical shift instructions, arithmetic shift instructions, and rotate instructions. So, in case of a logical shift instructions, they consider the contents of the register to be a bit pattern when the shift is made. In case of an arithmetic shift instructions, they consider the contents of the memory byte or a register to be a signed number. So, when the shift is made, the number is arithmetically divided by 2 in case of a right shift and multiplied by 2 in case of a left shift operation. And the third type of shift is a rotate shift. In case of rotate, the bits of the operands are rotated either towards the left or to the right side. So this is about shift operations. So going in detail about the different types of shift operations. So this tabular column will give you the different types of shifts. The first two are logical shifts. Next, second two are the arithmetic shifts, and last four with respect to the rotate operations. So in case of a logical shift, we have logical shift right and logical shift left. In case of arithmetic shift, we have arithmetic shift right and arithmetic shift left. In case of a rotate, we have rotate right and rotate left. That is one class of rotate. And other thing is rotate right with carry bit and rotate left with carry. So this is without a carry, you are going to shift the contents of the register, and including the carry bit, we are going to shift the contents of a register using through carry. So we'll see them in detail. So coming to a logical shift, it is divided into two types: logical left shift and logical right shift. In case of a logical left shift operation, moves each bit of a contents of a register left one by one, and the empty least significant bit is filled with a serial input which is a 0, and the most significant bit will be rejected. In case of a logical right shift, you are moving contents of the register bit by bit towards the right, and the least significant bit is going to be rejected here, and the empty most significant bit is filled with a serial input which is a 0. So if we see an example of a logical left shift, so consider these are the contents of my register. I am taking a 5-bit register which stores 5 bits of information. And when you look at the register, this end of a register is said to be called as a LSB, least significant bit, and this end of a register is called as a MSB, most significant bit. So, in case of a logical left shift operation, the contents of the register has to be shifted towards the left. So, from this end, the contents will be shifted towards the left. 1 will come here, 0 will come here, 1 will come here, 0 will come here. And the MSB bit will be rejected. This bit will be rejected. And the empty LSB bit, it will be filled with a 0, which is a serial input. In case of a logical right shift, the contents of the register are moved towards the right. So starting from this end, the contents will be moved towards the right. 1, 0, 1, 0. And in this case, the LSB will be discarded and the empty MSB bit is filled with a serial input 0. So this is a logical left shift and logical right shift. Next, coming to an arithmetic shift operation. The arithmetic shift is a micro operation that shifts a signed binary number either to the left or to the right. In case of a shift left operation, arithmetic shift left, it multiplies a signed binary number by 2. Whereas in case of an arithmetic shift right operation, it divides the number sign binary number by 2. So arithmetic shift must leave the sign bit unchanged because the sign of the number always remains the same when it is multiplied or divided by 2. So in case of an arithmetic left shift, each bit is moved to the left one by one and empty least significant bit is filled with a 0 and a most significant bit is rejected. It is similar to a logical left shift. Whatever is the logical left shift, that is same as an arithmetic left shift. In case of right shift, it changes. Each bit is moved to the right one by one and the least significant bit will be rejected, and whatever is their empty most significant bit, it is filled with the previous value of the MSB. So let us see an example. So at the left shift is same as a logical left shift. So we are moving the contents of the register towards the left. Okay. And this bit will be rejected, the most significant. And the least significant bit will be filled with a 0. This is left shift. In case of a right shift, you have to move the contents towards the right. So 1, 0, 1, 0. And LSB will be discarded or rejected. And in place of this empty MSB, we have to replace the old MSB. This is the arithmetic right shift. Next, coming to a rotate instructions. In rotate instruction, the bits of the operands are rotated either to the left or to the right. So this is something like a circular shift. The rotate instruction produces a circular shift operation. So bits shifted out at one end of the word are not, in this case there is no loss of information because you are just moving the bits of the register from one end to the other end. Then there is no loss of information and you are not discarding any bits or not appending any bits. So they are divided into four types: rotate left, rotate right, rotate left through carry, and rotate right through carry. So in case of a right rotate instruction, it shifts all the bits in the register. So if you look at an example of rotate right, so this is the contents of my register. I am taking an 8-bit register. This is an LSB and this is MSB part. So in case of a rotate right operation, the contents of the register are moved rotated towards the right. So starting from this end, so 0, 1. So this is an example of left rotation. The contents of my register are rotated towards the left. So if I see here, the contents of my towards the left. So it starts here 1, 0, 1, 0, 1, 1, 0, 1, 0, and this 0 which is an MSB will become an LSB. So see, this is left rotation. In case of a right rotation, the contents of my register are shifted towards the right. So 0, 0, 1, 0, 1, 1, 0, and this one LSB will take the place of MSB 1. So this is a right rotation. So you are just circularly moving the contents towards the left or right without any loss of information in case of a rotate right and rotate left. In case of a rotate right through carry and rotate left through carry, you are also including the carry bit along with the register contents. So the rotate left through carry instruction, it shifts each bit to the left, copies the carry flag to the least significant bit, and copies the most significant bit into the carry flag. In case of a rotate carry right instruction, it shifts each bit to the right, copies the carry flag to the most significant bit and copies the least significant bit into the carry flag. If you look at an example for this, so this is the contents of my register and this is the carry bit. So along with the carry bit, you are going to perform a rotate operation. That is called as a rotate right through carry. And you are performing a right carry. No, sorry, right rotate. In case of a rotate left through carry, along with the carry bit, you are going to perform a left rotate operation. So we call it as a rotate left through carry. So in case of rotate right through carry, the contents of my register along with the carry bit are rotated towards the right. So 0, 0, 0, 1, 0, 1, 1, 1, and this carry will come in place of MSB. In case of a rotate left through carry, 1, 1, 1, 1, 0, 1, 0, 0, and this MSB will be here in place of carry. So this is a rotate left through carry. So these are the different types of shift instructions which are logical shift left and logical shift right, arithmetic shift left and arithmetic shift right. And in case of rotate, we have four operations like rotate left, rotate right through carry, and rotate left through carry. So these are the different types of shift operations. So with this, we have completed data manipulation instructions. Thank you.